Okay, I'm back with another example. This one's just going to be forming water from hydrogen and oxygen. Giving you the numbers there, 4 moles of hydrogen combined with 3 moles of oxygen gas. At equilibrium, we see 1 mole of water. All right, we're going to determine the equilibrium amounts of hydrogen and oxygen, just like the previous example. This time we'll also calculate the percent yield. And as before, I've set up this ice table, but just keep in mind you'll have to do this on your own on questions. That involves writing a balanced reaction. Okay, so hydrogen, I started with hydrogen, oxygen given water. I'm sure you've done this before and balanced the hydrogens with the two. Okay, so these are just the numbers I've given. I'm afraid that looks like a 10, but it's a 1. All right, so we have 4 moles here, 3 moles. We always start with 0 of this stuff. Okay, at the end, we had 1 mole. That was given to us in the question. That tells us the change. So we added 1 mole of water. And remember, we apply stoic to the change row. Okay, so the oxygen change is going to be this 1 times the molar ratio desired over given, which is going to be 1 over 2. Okay, that's just going to give us a half. And that's negative. Things on the left of the arrow go down, so their change is negative. Okay. For hydrogen, it's this 1, and we multiply that 1 by the molar ratio, which in this case is 2 over 2. That's just going to give us 1. And again, the math doesn't tell me it's negative. This might look funny in math class for sure. It's minus because these guys are reacting to form this one. This one goes up, these two have to go down. Okay, get the equilibrium amounts. We do the initial minus the change. So there's going to be 3 moles of hydrogen left, and there's going to be 2.5 moles of O2 left. All right. Now I'm going to show you how to do percent yield. To do percent yield, we just need to know what the maximum amount of H2O is produced. We do the equilibrium divided by the maximum. So we need a limiting reagent here. Okay. I'm actually going to set up a new ice table. Same reaction though. Okay. So 2H2 plus O2 giving me 2H2O. The reason I'm doing this is I want to find out the maximum equilibrium amount of H2O so we can calculate percent yield. All right. And to find the maximum amount, you assume that all of the limiting reagent reacted. Now, it's not always easy to just come up with the limiting reagent on your own. There's different little tricks. Let's be smart about this. So in our reaction, there's 2 hydrogens for every oxygen. Okay. So just assume, let's say all the hydrogen reacted, all 4 moles. Half that much oxygen would react, which would be 2. There's enough oxygen for that. That means this is our limiting reagent. If you would have chosen oxygen, if all 3 moles react, that would require 2 hydrogens for every oxygen. That would require 6 moles, which we don't have. Okay. So this is our limiting reagent. Let's say it all reacts and there's none left. We apply stoic to the change row. So the oxygen, it's going to be this 4 times desired over given. So there'll be 1 mole of oxygen left. We don't actually care about that. You could totally skip this because all we really care about is this here. Okay, so this guy, it's going to be this 4 times the molar ratio. So the maximum amount of water we can get is 4 moles. Remember how to do percent yield? It's the equilibrium amount divided by the maximum amount. All right. We were told 1 mole is present at the end. The maximum possible amount would be 4. So this is going to be 25% yield.